Alrighty gang, we have the dreaded AA gradient. Now, trust me, it's not as complicated as it seems. So let's just step through our AA gradient nice and slow. What it's really looking at is the difference between the amount of oxygen that was available in our alveolus and how much of that actually made it through to our arterial blood. So for the amount of oxygen in our arterial blood, we can find that in our arterial blood gas results, our ABGs. And for the oxygen available in the alveolus, we will actually have to calculate this, and so we have this formula. So in order to find the amount of oxygen that would have been available to us in our alveoli, we first need to find the amount of oxygen that was available in the inspired air. Now, this will usually be given to you in the question. Next, we'll also need our PaCO2, which can also be found in our arterial blood gases. So you can get that one from your table of results. And we'll need our RER, or our respiratory exchange ratio. Now, you may be given the means to calculate this one, but it is fairly consistent and usually safe to assume 0.8. Now, I do want you guys to note my setting out on this slide. So I very deliberately put those brackets in there. Again, when you're doing the formulas and the math, it's really important that you do your brackets first. Because if you just put this straight into the calculator, you won't get the correct answer. So what you actually need to do is first the PaCO2 divided by the RER. You get that answer. Then you'll enter a new line into your working that will be the oxygen in the inspired air minus the answer you got from inside the brackets. You must do them as two separate operations, otherwise you won't get the correct answer there. Okay, so let's take a closer look at what this actually is telling us. So if we use some rudimentary numbers here and we just assume that there is 100 available oxygen in the alveolus, and we look at our oxygen in arterial blood and there's 75 in there. That means that of the 100 that were available, 75 got across and 25 didn't. So the difference between those two is 25. So 100 minus 75 equals an AA gradient of 25. Whereas if there was only 50 available oxygen that made it from the original 100 in the alveolus into the arterial blood, that means that there was 50 left over that didn't make it across. And so that's a worse oxygenation for us. So ideally, we want to see lower AA gradients, meaning that more oxygen is getting through that respiratory membrane and into our arterial blood. If the AA gradient is high, that's meaning that there's a big difference between the oxygen that was available and the oxygen that actually made it into our blood. And when we see that happening, we're saying, okay, well, there's some kind of issue with the oxygen getting from the alveolus into the arterial blood. So we can calculate our normal AA gradient. Now, usually I think they will give you this formula, but it is a fairly easy one to remember. So if you can memorize it, do. And we will compare what the normal AA gradient was, what we were expecting, to what we actually got. Now, if we got an AA gradient that was normal or lower, we would be very happy with that, because a lower AA gradient means that there's plenty of oxygen getting across into the blood. If the AA gradient was higher than what was predicted, that would be a concern and indicate that there is possibly a problem with that respiratory membrane. So you're thinking diffusion block there. An example of that might be like in pulmonary fibrosis or emphysema. We have destruction or thickening of that respiratory membrane, which makes it harder for oxygen to cross. We of course have our ventilation perfusion mismatching, which you have a whole video on. So that could be another reason that that AA gradient would be increased. So these would indicate a type 1 respiratory failure, and you should definitely make sure that you know what type 2 respiratory failure is as well and how to pick it up. I'm not going to tell you that in here because I know that you've already got that.